Hey folks, welcome back to our next lesson. So today we're going to be working on factoring polynomials. It's something that you have seen before and you just refreshed by reading that textbook section first. However, it has been a while, so we're going to go over 3 that you've seen in Algebra 1, and then next class we're going to go over 2 factoring methods which you probably have not seen before, or if you have, they were glossed over very quickly. The ones we're going to look at today are factors and sums, difference of perfect squares, and greatest common factor. At any point, you can pause this Delta Math video and try the Delta Math problem sets. If you're being frustrated with it, come back, watch this again, or go ask Live Gallagher in the Zoom chat for some help. Let's take a look. So the first blast from the past we're going to look at is factors and sums. You've seen it before, we're just getting all the cobwebs off. We know that this is going to be done by factors and sums because we have our 3 terms. The leading coefficient is 1. There's an invisible 1 here. And we're going to be able to find terms that add to the second term and multiply to the last. So our last term here is 12. So I need to think of all the numbers that multiply to 12. 1, 12, 2, 6, 3, 4. Anything past that is just repeating. And I need to figure out which ones of these add up to positive 7. Well, this is 13, that's 8. These two add up to 7. So I can rewrite this as x plus 3, x plus 4. And we can check this using the area method, or I'm going to show you how to check it using Desmos a bit later in this lesson. Now, suppose we had another one of these. Suppose we had x squared minus 1x minus 12. Here, the negatives are what's getting us, because I need 2 numbers that multiply to the last term, so that's going to be to negative 12. And they're going to have to add up to the middle term, which is negative 1. Notice I'm including the negatives, that's pretty important. So it's going to be very similar, 1 and 12, 2 and 6, 3 and 4. But because that 12 is negative, I am subtracting. And I'm trying to subtract to get to this negative 1. That's right here. Well, 12 minus 1, that's going to be 11, so it won't work. 6 minus 2, that's going to be 4, so it won't work. 4 minus 3 is negative 1. So I know those are the numbers that are going to work. I'm going to have x and 3 and x and 4. And since the 1 in the middle is negative, the bigger number is going to be negative, so that's going to be 4. Positive is going to be the smaller number. And I can check it by negative 4 plus 3 is going to give me negative 1. That's factors and sums. You might want to pause this video and do the factors and sums that's on Delta Math. Okay, so I'm assuming you did that and you paused the video. Let's move on. Difference of perfect squares. How to tell that there's a difference of perfect squares? You have 2 terms, not 3. There will always be subtraction. That's back from the part where it says difference. Remember, difference is meaning subtraction. And we need perfect squares. Some numbers that are multiplying the same number together. This is one of our examples. We have 100, that's a perfect square. X squared, literally x squared, that's a perfect square. Minus, so we have subtraction. 36, that's a perfect square. And y squared. And what I do is I just take the square root of both terms. I'm going to have 2 factors, one with plus and one with minus. So let's see. I'm going to set it up. Well, square root of 100 is 10, so they both have 10. Square root of x squared is x, so they both have x. Square root of 36 is 6, so they both have 6. Square root of y squared is y, so they both have y. Now I just really need to keep in mind this part. One has to have addition, one has to have subtraction. So addition, subtraction. It doesn't matter if you put subtraction first and addition second because they're being multiplied together. Let's see another example. Let's say 49 minus 144c squared. Well, we're going to do the same thing. I'm going to split it up. 49 is 7 squared. 144 is 12 squared. And c squared is just c. squared. And remember, this is addition, that's subtraction. Again, you can switch the order. A non-example, one that we cannot do by difference of perfect squares, would be the exact same as the first one, but with addition. This last one cannot be done by difference of perfect squares because it has addition. And the name of difference implies that it has to have first subtraction. This non-example here that's in red would be called a prime expression. We can't factor it anymore. Well, we can factor a little bit using greatest common factor, but we'll get to that in a second. Now would be a great time to pause this Delta Math video and go do that difference of perfect squares set that's waiting for you. Okay, I'm assuming that you've gone and done that difference of perfect squares set. Let's move on to greatest common factor. Now, greatest common factor, the things to look for, it has 2 or 3 terms, and every single term shares a factor. That's it. Now, in order to do it, you take the factor out, kind of like reverse distribution. You're going to rewrite as an expression when the factor is divided out, and you are always looking for other methods afterwards. It's entirely possible that you first take out a greatest common factor, and then you can do something else, as we'll see in our second example. Let's take a look at our first example, right here. So, I have 3x squared minus 6x. Well, 3 and 6 share a common factor of 3. X squared and x share a common factor of x, so that's going to come on out. And then I'm just going to divide each one of these terms. 3x squared divided by 3x, only an x is left. 6x divided by 3x, only a 2 is left. The sign doesn't change. Here, because I'm left with this binomial that has no exponents, and because I'm left with this monomial, I can't do anything else. I don't have any other methods that I can apply. So it's considered fully factored. Let's take a look at the second one. And actually I'm going to move the second one down to here to make it easier. So, if I look for integer GCFs, well, this has a 1 in front, this has a -9, this has a +8. They don't share any factors in common. There's no number that goes into 1 and -9 and +8 besides 1, but that doesn't do anything. So now I look at the variables. Well, that has an A, that has an A, and that has an A. Okay, so an A goes into each one of these. I can pull it out. Well, this a to the third divided by a is just a squared. Bring down the -9. A squared divided by a is just a. Bring down the +8. 8a divided by a is nothing. The a's cancel out. I'm just left with the 8. Now, here we have it. We have this a monomial. I can't do anything with that. But I can more fully simplify this. It's factors and sums. Leading coefficient is 1, and I do have numbers that multiply to 8 and add up to -9. So, if I have 8, I have 1 and 8, 2 and 4 are the factors. This is a +8, but this is negative. So that means that these numbers are going to be both negative and negative, negative and negative. Well, -1 plus -8, this one right here, this will add up to -9. So, this in the blue box will become a minus 1 times a minus 8. And don't forget to bring this part down. That's GCF. Always look for other methods after GCF. It's very important. Now, suppose you wanted to check your answer to this second one. You did a lot of work, you want to check it before you go and plug it into Delta Math, because you really want to avoid that you got something wrong and you have to do another problem. Well, here's how we're going to check it. I'm going to go to Desmos, And I'm going to plug in first the original, the a to the third minus 9a squared plus 8a. Only difference is I'm going to replace all the a's with x's because I'm graphing. And I want this graphing software to know what the heck I'm talking about. Oh, x. Cool, it gives me a parabola. Well, now I'm going to check it by plugging in this last one, this fully factored form. Again, I'm just replacing every a with an x. If we're right, I should have the blue graph completely overlapping the red one. If I click the blue, it goes away. You're only seeing one graph here because they're completely overlapping. Now this does have its drawbacks. For instance, suppose I were to type in the somewhat factored but not fully factored form that we had here. It still overlaps completely, but it doesn't tell you it's fully factored. You need to be able to recognize how to fully factor these things. Other than that, Desmos is a really great way of checking, because suppose I got down to this one but I forgot about the negatives and I said they were both positive. We can see these are two different graphs. This is not the correct factorization because it doesn't give the same graph. I hope this helped. Give that delta math a shot. So, hopefully by this point you've given all those delta math problems a shot. You've also looked at how to identify each method, because you do have a delta math section on that of how to identify when to use each method. So what could help with that is a flowchart. I put it on the Google Classroom as a link here, and it just says like how to use each one of the factoring methods. It's really handy. There's some stuff on there that you're going to say, well, we didn't cover this in this lesson, and that's okay. We will get to it later. But right now, I just need you to know that flowchart and be able to recognize the stuff we have learned on it. Give that delta math a shot. If you have any problems, you know where to reach me either in the Zoom chat or in office hours. Good luck, folks.